I'm on a whole new
Hey guys, today we're going to talk about our solar system. So let's get started. Now our solar system is made up of the sun, 8 planets, their moons, dwarf planets, asteroids, comets, and meteors. First, we'll start with getting to know our sun. The sun is just a medium-sized star, yellow dwarf. It is about 1.4 million kilometers in diameter. It would take 10 Jupiters or 109 Earths to fit across the sun. This makes life on our planet possible by giving us great amounts of light and heat. Composition of the sun. The sun is primarily made of hydrogen and helium. That's 90% hydrogen, 9% helium. So small amounts of other elements, including oxygen, neon, and carbon, are also found in the sun. So that accounts for that 1%. In the chart provided, there's a breakdown of those compositions that I mentioned, with the 90% being hydrogen, 9% being helium, and the 1% comprised of the other elements, as indicated by the pie graph on the right. The planets and the sun. Now, the distance between the planets is measured using a special type of system of measurement. And we need this system, or it was adopted rather, because of the large space between planets and the sun. So let's talk about this system of measurement. It has coined the term astronomical units, or AU for short. AU is used to measure distances in the solar system. The Earth is about 150 million kilometers or 93 million miles on average from the sun. That distance is 1 AU, or 1 astronomical unit. Planet mnemonic. Now, most of you guys should have been exposed to the planets at this point, and there are different improvisations of that very mnemonic that helps people recall what the planets are. I won't get into that, but you do need to know that the order is as follows: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So let's talk about these planetary zones. The first zone contains the rocky terrestrial planets that span between Mercury all the way to Mars. The asteroid belt divides the first and second zones. The second zone contains the gas giants that range from Jupiter to Neptune. The third zone goes from the orbit of Neptune out to about 50 AU, and this includes Pluto and the ice dwarfs in the Kuiper belt. The inner planets. These planets are considered rocky, and they are called terrestrial, from the Latin word terra, which means earth. These include Mercury, Venus, Earth, and Mars. These are the 4 inner planets. Next, the outer planets. Jupiter, Saturn, Uranus, Neptune. And I guess if you wanted to include Pluto, however, it's not regarded as much of a planet other than the dwarf planet. These are called the gas giants, and they are made of the lightweight elements hydrogen, helium, carbon, oxygen, and nitrogen. So again, Pluto, not really a part of the planet system that we know of today, but this dwarf planet is made of rock and is considered to be extremely cold. Now, let's talk about the planets. And it is a lot of information, so I'll try to be as concise as possible. We'll start with Mercury, which is the first planet. A revolution period for Mercury spans 88 days. A rotation takes 58.7 days. Mercury has extreme temperature fluctuations, which means changes in temperature that range from 800 degrees Fahrenheit in the daytime to 270 degrees Fahrenheit at nighttime. It has no moons, it supports no life, and there's almost no atmosphere, although you can say that there are trace amounts of hydrogen and helium. Just trace amounts, not a lot. The diameter is roughly 4,878 kilometers, or 3,031 miles, and that's about 1/3 the size of Earth. The surface conditions consist of craters with smooth plains, very similar to our Earth's moon. The closest planet of all, as I mentioned, and it is also the fastest moving planet. And unlike the other ones, it has a very elliptical type of orbit, which makes it unique in its pathway of travel. Now, moving on into Venus. Venus is regarded the hottest planets, and there is a very logical reason for that. The atmosphere is very thick. It contains about 96% carbon dioxide and 4% nitrogen. In these clouds are large amounts of the caustic, very dangerous sulfuric acid. The combination of these two things causes the greenhouse effect, where heat is trapped inside of that atmosphere and contained where it's not able to leave, and essentially cooks the planet, making it very hot. Now, a revolution takes about 7.5 months, and a rotation takes about 8 months. Venus features no moon. It has intense high pressure, which means that things would almost implode upon entering Venus's atmosphere. In fact, there have been some investigations where that has been the case, and they found out the high pressure can affect things. The average daily temperature is about 464 degrees Fahrenheit. The diameter is roughly similar to that of the Earth, as well as in mass. So in terms of relative size, Venus is probably our closest twin. Moving on. Earth, the wonderful blue planet that supports life. A rotation takes about 24 hours, or 1 day. A revolution takes 365 days. The diameter is roughly 12,756 kilometers, or 7,926 miles. The atmosphere has about 78% nitrogen, 21% oxygen. The surface conditions entail it being our water world planet. The temperatures vary between negative 127 degrees Fahrenheit, which is definitely cold, and 136 degrees Fahrenheit, which is much warmer. And those are the extreme conditions, but all in all, the temperature is definitely great for sustaining life. So therefore, we live here. We also feature one moon on Earth, one moon. And a moon will be regarded as a satellite. It's the only naturally occurring satellite. It's an object that's emanating or floating in space around another object. In this case, we have one natural satellite, the moon. Moving on, Mars. Now, Mars takes about 1 day to rotate. Our revolution takes 686 days. The diameter is 6,787 kilometers or 4,222 miles, which is half the size of Earth. Now, the atmosphere of Mars is 95% carbon dioxide, 3% nitrogen, and 1.6% argon. There is no oxygen on Mars currently. The surface conditions entail it being a red planet, which is due to a high amount of iron oxide, which we know as rust. So it's called the red planet in many regards. Now, it features craters and canyons and all the like, but one defining features of Mars is that it has the largest volcano known in our solar system. And this is entitled the Olympus Mons, which spans 15 miles high. The temperature on Mars ranges from a high of 68 degrees Fahrenheit to a low of negative 220 degrees Fahrenheit. Now, as far as life, Mars is one of those unique planets that's believed to have once contained water. And so there was a possibility, and even now there's a possibility that suggests that because there may be water under the sand, that Mars may be able to support life. Mars also features 2 satellites. They are known as Phobos and Deimos. Those are the 2 moons associated with Mars. Moving on, we have Jupiter. Now, a rotation takes about 9.84 hours. A revolution takes 11.862 years. So revolution takes quite a bit of time. The diameter of Jupiter is roughly 142,796 kilometers, or 88,729 miles. This is 11 times the diameter of the Earth. Jupiter is so big that all the other planets in our solar system could actually fit inside of Jupiter if it were hollow. The atmosphere of Jupiter is mostly hydrogen at 90% and 10% helium. Very similar to the makeup of the sun, if you think about it in terms of atmosphere. Now, it has a great red spot, which everyone's aware of, and it is where the great storm is taking place. It's a very large spot. Now, the surface conditions are made of gases and liquids, and the cloud tops average about 153 degrees Celsius. And no, it cannot sustain life. It does feature one ring, and it has at least 40 moons, 40 satellites, if you will, and counting, with the most popular ones being Callisto, Europa, Ganymede, and Io. Next, we have Saturn, which is the second largest planet behind Jupiter. A rotation of Saturn takes 10.2 hours. A revolution takes 30 years. The diameter of Saturn is 120,660 kilometers, or 74,600 miles. 764 Earths could fit inside of Saturn. The atmosphere contains mostly hydrogen gas, which is mostly 97%, and 3% helium. And there's about 0.05% methane and ammonia. The surface conditions obviously suggest that it is very gaseous. It does actually feature a rocky core, a liquid metallic hydrogen layer above that core. The temperature, or average temperature rather, on the cloud tops is 185 degrees Celsius. Now, it cannot sustain life. And as far as rings are concerned, there are 7 divisions that are made of ice chunks and rock. And at least 33 moons are known, with Titan being the largest of the natural satellites. Now, Uranus, or some call it Uranus, depending on the pronunciation, but the information about it remains pretty constant. It has a rotation of roughly 18 hours, or 17.9 if you're being specific. The revolution takes about 84 years. It has a diameter of roughly 51,118 kilometers, or 32,600 miles, which is 4 times the diameter of Earth. The atmosphere is 83% hydrogen, 15% helium, and 2% methane. Uranus' blue color is actually caused from the accumulation of methane gas in its atmosphere. The surface conditions feature frozen temperatures as gaseous planet with a molten core. Its temperature in its cloud layer is 350 degrees Fahrenheit, and it cannot support life. It also has 11 rings that are made of rocks and dust. And finally, it features 22 moons, or 22 natural satellites. Lastly, we have Neptune. Neptune features a rotation of 19.1 hours. A revolution takes a whopping 164, almost 165 years to occur. It has a diameter of 48,600 kilometers, or 30,200 miles. The atmosphere is, again, 74% hydrogen, so mostly hydrogen like the other gaseous planets, 25% helium, and 1% methane. The surface conditions suggest that it is composed mostly of ice, hydrogen, and helium. The average temperature is around negative 200 degrees Celsius. It cannot support life. It has 3 rings composed of rocks and dust. And it has 8 moons, with some of the popularly known ones being Nereid, Proteus, and Triton. Now, this giant frigid planet has a hazy atmosphere and very strong winds. So, we've talked about the planets, and I wanted to at least kind of give you an idea of the various tilts. And if you notice, some of the planets have interesting tilts as they orbit the sun. Mercury has a 0.1 degree tilt. Venus has 177 degrees of a tilt. The Earth is about 23 degrees. Mars is 25 degrees, which is very similar to ours. Jupiter has 3%. Saturn is 27%. Uranus is 98%, or 98 degrees rather. And the Neptune has 30 degrees. And if we were including Pluto as one of the planets, it has 120 degree tilt. So this talks about the tilts of the planets and how they rotate. And basically, they have an interesting setup for a few of them. If you look at Uranus specifically, its rotation appears kind of sideways. And if we're looking at other unique features, you should notice that Venus rotates in a direction that is opposite to the other planets. So Venus has an opposite rotation, and its degree of tilt is vastly larger than that of the others. Also, Uranus kind of tilts at a high angle, and it rotates sideways, but still in the same direction as the other planets, Venus being the only one that's unique. So this completes our presentation on the planets, and hopefully we've shed new light on the various characteristics that make these planets unique.